All right, hey everybody, welcome to this HelperBot dashboard video. Today, we're going to talk about the HelperBot dashboard. We're really excited to roll this out. You'll log into your organization and see it in there one day, hopefully very soon. But this dashboard is going to give us some insight on HelperBot's classifications, his accuracy, and really the purpose of this dashboard is to help you tune your approval and denial thresholds, your green and red thresholds, so that you can find the perfect balance between letting HelperBot do as much work as he possibly can with a error rate that you're comfortable with. So we're really hoping this is going to be helpful for you. As a refresher, every photo that is submitted to your organization is classified and given a confidence score, and where the value of that confidence score determines whether the photo falls within the green or the red threshold. All right, and these thresholds, I'll actually scroll down so you can see how the data gets changed. But if I actually need to move out. I was drilled down into the data. So if I change this green threshold to, let's say, 99%, boom, the graph will change. Additionally, if I change the red threshold, let's put it at 1%. Actually, I guess that would be 10%. Yep, that changes the graph as well. These decimals are, or the percentages are represented by decimals in this reporting software. That's just one of the limitations. So as I've been showing you, 75% would be 0.75 and 50% would be 0.5. All right. So we'll move back to our original thresholds of 80% and 40%. And we're going to start out talking about this pie chart. And later in this video, we'll move up to the graph up top, but we're going to start with the pie chart. And this represents HelperBot's accuracy, his correctness. It's based on your past classifications along with your approval and denial history. And so, if I hover over this green section, it's saying that for all the photos submitted to my organization, HelperBot is right and correct about them 77% of the time. And that includes green photos and red photos. All right, now if I move over into this incorrect slice, that's telling me that 5% of the time, HelperBot is giving the photo the wrong classification. Or if you have auto deny turned on and auto approve turned on, he's making a decision and getting that making a wrong decision 5% of the time. All right, and then we have this yellow section. This is representing the work that you have to do. So 18% of the photos HelperBot is not sure about, and so a human is going to have to review those photos. All right, so let's. It's also pretty cool because you can drill down into the data. So I can drill down into this 5% incorrect slice and see, oh, interesting. 22% of the 5% of incorrect classifications are false positives. So they should have been denied, but they were actually approved. And then, on the other end, 78% are false negatives. All right, so you can drill down into the data. And really what we're trying to do, as I alluded to at the beginning of the video, is we're trying to find a good balance between the work that we want HelperBot to do for us with an error rate that we're comfortable with. So let's just say we want HelperBot to do all the work. So let's put this at 0.5 and 0.5. So actually, I'm going to have to go back and do that again. So in other words, there's no yellow band HelperBot is making a decision on every single photo. If I do that, well, 91% of the time he's going to be correct. And then additionally, 9% of the time he's going to be incorrect. And then I can drill down on this data and say, okay, so of those incorrect photos, 26% are going to be false positives, and then 74% are going to be false negatives. So maybe, in this red section, what this is saying is the photo should have been approved, but HelperBot classified it as denied. So in a worst case scenario, the student gets a denial email and they just have to submit a new photo. And hopefully it's a better photo. So that might not be as big of a deal for you. This green section will probably be a bigger deal. Again, that's a decision that you have to make from a business standpoint. So that'll be unique to each card office. But yeah, in this scenario, HelperBot is doing all the work. Now let's say we really care about accuracy. Okay, so we're going to say, actually, let's just do 100%. Actually, that would have to be 100% here, and we'll do 0.001% on the red threshold. All right, so here we go. There's no red slice. HelperBot is doing 7% of the work for me. Wonder what it is at 0.99. Okay, so HelperBot is now doing 16% of the work for me. There's a very, very small error rate. You can barely see it. I can barely get my cursor on it. And then, I'm left with about 85% of the work, 84% of the work. So those are extremes. So we're trying to balance this as best we can. So something that will probably be very helpful is this distribution graph here. All right. So along the bottom, I just kind of want to orient you to what's going on here. Along the bottom, we have our confidence scores. So 100% being the highest possible confidence score. We have 50% in the middle, and then at the very end here, we have 0%. That's the lowest possible confidence score. So we see at 0%, there's about 9,000 photos that have been denied. And then over here at a 100% confidence score, about 7,000 photos have been approved. So hopefully, the higher the confidence score, the more approvals. The lower the confidence score, the more denials. And then as we work our way down the graph, the denials will start to decrease and the approvals will start to increase. Same way, if I move over to the other end here, the approvals will start to decrease and the denials will start to increase. And then we have this inflection point at about 32.5, just under 30%. This graph is distributed by 2.5%. Okay, so it's pretty granular, but not overly granular. But we have this inflection point. All right, so we want to find a sweet spot for our approval threshold. So let's try and look for a section on this graph where the curve starts to flatten out. Let's pick 82.5% for that. So I do 825. Okay. And then let's do the same over here on the denial side. So maybe we could do 10%. Yeah, let's go ahead and do 10%. That's 0.1. And let's see what our graph looks like. Okay, so HelperBot is going to do just over 70% of the work. Or he could, if you choose to have auto deny and auto approve turned on, he'll do just over 70% of the work. You'll be left with about 28% of the work. And then the there's this 1% incorrect section, and actually that HelperBot's still doing that work, so it's just about 72% of the work that HelperBot's doing, but 1% of that work will be incorrect work. So let's just, out of curiosity, let's drill down into that data and see what we're looking at. Okay, so about 25% of those errors will be false negatives, and then 74% will be false positives. All right, so not too bad, not too shabby. Let's say we want to start to make this error rate smaller, that 1%, but we want to make that 1% even smaller. So let's get a little more strict with our thresholds. Let's move up to 90% in the approval threshold. There's 90. And then in the denial, we'll get a little more strict, and we'll move it up to 5%. All right. Now we have 90% on the green threshold, 5% on the red. Let's take a look at our graph. All right, so the work that HelperBot will do for us has significantly decreased. He'll do about 60% of the work and leave 41% up to us. And then we have a 1% error rate. But that's actually been cut in half. It was 0.88 K in the last example, and now it's 0.773 K. So we can drill down into the data and take a look at that. Our numbers have decreased. So yeah, really interesting. One thing I want to say about this yellow band, really what we're talking about here is delegation. How much of the work are we willing to delegate to HelperBot? And anytime you delegate something, there's going to be some errors. You think of a coffee house manager, and they have different baristas, and the coffee house manager knows the menu like the back of his hand. He can make every drink perfectly, and you basically trust your ability as the manager to make the perfect specialty drink. Now, unfortunately, you don't have the bandwidth, right? Your coffee shop is busy. You can't make every drink, so you gotta start to delegate that work to your baristas. And obviously, you're going to train them the best you can, but there's always going to be some human error involved. But you're willing to accept that error because you get to serve more customers. So in the same way, I like to share that analogy because that's really what's happening with HelperBot. Whether you're delegating the work to HelperBot or a student worker, there's going to be an error rate. Fortunately, with HelperBot, we can predict what that error rate will look like, and so that's what these thresholds are helping us do. Balance the amount of work that HelperBot's going to do with an error rate that we're comfortable with. All right, so we have also included these sheets up here, the approved and denied sheet, and so this is this represents all the approved photos. Okay, and this represents all the denied photos. All right, so in the approved photos sheet, the median confidence score is 92%. So, for example, a brief lesson in statistics, the median number is basically the value that separates the higher half of the approvals from the lower half of the approvals. So this 92% is right in the middle of those approved photos. And then same with denied. 2% is that median confidence score. And then we can talk a little bit about standard deviation as well. Standard deviation is most useful when data is normally distributed. And so, we haven't done the statistical analysis to ensure that this graph is perfectly normally distributed. But it's pretty close, as it looks like a bell curve. And so, we know that the standard deviation is 20%. And really, it's a measure of spread. How spread out is this data? So something you can do that might be helpful is to take this median confidence score and subtract the standard deviation and use that as your approval threshold. And if you want to be a little more lenient, you could take this average confidence score and subtract the standard deviation from that and use that as your approval threshold. So let's go ahead and do that. Let's do subtracting that. Let's do that first example. So we'll set our approval threshold at 72%. And then we'll actually do the opposite here. So instead of subtracting from the median confidence score on the denial sheet, we'll add the standard deviation there. So this will move up to 23.6% as the denial threshold, 23.6. All right, and then we can scroll down to our graph and check it out. So we have a 3% error rate, but HelperBot is doing 84% of the work. And then we have, just 17% of the work is left for student workers or you in your card office. All right. So let's say we are okay with a greater error rate. We want to do even less work. So we'll subtract 20% from our average confidence score. That'll give us, 63.6% as our green threshold. 63.6, I think is what I said. And then we'll go over to our denied tab, and we'll add 21.6% to our average confidence score, 11.1%. That'll give us 33.7%, it looks like, or 32.7%. So 32.7%. All right. So now HelperBot is doing 90% of the work. 10% of the work is left for us, and there's a 4% error rate. So we can drill down into the color, and yeah, so over half of the incorrect section is false negatives. And then, the rest are false positives. So this really isn't too bad. Okay. So yeah, I hope that has been really helpful for you. Again, the goal of this dashboard is to help you tune your thresholds and to help you really customize those as best you can. So we're hoping this will be a tool that you can use to do that. And please reach out if you have any questions. I know this was kind of a long video, but we thought it was worth planning. So yeah, give us your feedback and please reach out if you have any questions. Thanks.